What's cracking, guys? In this video I'm covering multitask prompted training enables zero-shot task generalization by this huge group of people here, and all of them came from this thing called BigScience workshop. Let me show you here. So a 1-year-long research workshop on large multilingual models and datasets. So they took inspiration from scientific creation schemes such as CERN and the Large Hadron Collider, and it's basically a collaboration between various companies, and the whole effort is bootstrapped by HuggingFace, GenC, and this Idris company, and they even have a supercomputer on their disposal, so like 28 petaflops supercomputer located near Paris, France. So yeah, if you're interested, if you fancy training huge language models, do check out this BigScience workshop. And yeah, I mean, outside of HuggingFace and these companies, there are many other supporting institutions like Mila, Stanford, even Microsoft here. So it's a huge thing. Other than that, the model, the T0 model I'm about to cover is already published on Hugging Face Hub, so you can find all of the versions of this T0, T0+, T0++ models are already here. And additionally, the model card is already available, as well as this small widget. And if you're not familiar with Hugging Face, what basically happens here is that once somebody trains a model, they can publish it to this hub, and they're responsible to create this model card because they will enable people to use that model. So that's in their best interest, as well as in the best interest of the audience, of the people who are going to use this, of customers. And finally, they have this small applet in this widget style applet where you can run the model in the background. So we can just click compute here, and the T0 is gonna do classification on this sentence. So we have last week I upgraded my iOS version, and ever since then my phone has been overheating whenever I use your app. Select the category for the above sentence from mobile, website, billing, and account access. So you can see that the prompt here is in a natural language form. You don't have just a sentence and then the output. You have the prompt, and then you have the categories here, and the model finally figures out the correct category. So if I were to change website to iOS, because that's a word that appears here, I guess it's gonna now output iOS. If I press compute here, it's gonna output iOS. Bottom line, you can play with T0 already, or you can, like here in this small widget, or even better, you can download it locally and then start the whole thing. Other than that, they, aside from models, they also open sourced this tooling they were using to collect the prompts, and we're gonna see what those are in a second. But yeah. All in all, huge kudos to the whole organization for making all of this public and usable for others. Okay, getting back to the paper, let's dig into it. So, large language models have recently been shown to attain reasonable zero-shot generalization on a diverse set of tasks. So that's the GPT3 paper. It has been hypothesized that this is a consequence of implicit multitask learning in language model training. Can zero-shot generalization instead be directly induced by explicit multitask learning? So basically, the hypothesis is the following. When you're optimizing the language modeling objective, so you're trying to predict the next word in the sentence, the model basically figures out that it's way easier to learn how to solve certain NLP tasks, such as summarization, such as question answering, which are relevant to us humans, in order to have an easier time to predict the next word. So all of those are implicitly learned as a consequence of trying to minimize the cross-entropy loss on the language modeling objective. The concern that the authors expressed here is that maybe, just maybe, those models are actually training explicitly, and we just don't know about it, so we call it implicit multitask training. We're gonna see that in a couple of minutes. Anyways, they say here the model attains strong zero-shot performance on several standard datasets, often outperforming models up to 16x its size. So they were comparing, as we'll soon see, this model T0 with GPT-3 family of models, and oftentimes this model outperforms GPT-3, which is super amazing. Okay, let's continue here. I mentioned the problem with implicit multitask learning, and they raise the concern here. So yet it is an open question how implicit this multitask learning really is. For example, there are many websites that simply contain lists of trivia questions and answers, and this data is precisely supervised training data for the task of closed book question answering. So let me open up that website. Okay, so here is like an example of a website where we have those answer and question types of text. So you can see here what geometric shape is generally used for stop signs, answer octagon. What is Sinophobia, answer fear of dogs. So you can imagine that while the model was trying to predict the next word, it was actually learning how to answer this question, because once you prompt it with this thing and then you force it to answer like this, you're basically teaching it arguably how to do the question answering in this closed book setting. And you can imagine similar documents somewhere in the huge data set that GPT-3 and T0, T5 models were using for training, and that the implicit multitask may actually be explicit, just that we are not aware of it. So therefore, they insist on training this model explicitly and see whether that increases the zero-shot generalization, whether we can like get off with smaller models, and whether we can have more robustness to those natural language prompts. And so they say here, our goal is to induce a model to better generalize to unseen tasks without requiring massive scale, as well as being more robust to the wording choices of the prompts. And that's very important because we see more and more lately like the prompt engineering type of job, where the whole point of someone's job is to find the correct prompt in order to squeeze out the additional performance from the language model. Anyways, okay, let's see how T0 is actually trained. So there are multiple tasks they used. We're gonna see those in a bit detail a bit later, but here are a couple of examples. So we have summarization task, and you can see like the template here is the picture appeared on the wall of a pound land store on Wymark Avenue, blah, blah, blah. So that's the question or the text. And then you have how would you rephrase that in a few words. So that's the natural language prompt. And the thing is, this prompt here, so they made, this whole group that wrote this paper, they made an open call and they asked for contributors who would create novel creative prompts for these types of examples. So summarization task does not have only this single type of prompt. They have multiple prompts. I think it's 8.1 on average or something. Anyways, the model is expected to regress this type of a sentence: graffiti artist, Banksy, blah, 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 blah. Okay, so other than that, we have paraphrase identification tasks. So you can see here, how is air traffic controlled? That's one question. Then we have, how do you become an air traffic controller? That's a second question. And then we have the prompt. Pick one. These questions are duplicates or not duplicates. And the model is supposed to say not duplicates in this specific case. So you can see that, again, this is a particular template for this particular task. And there can be many more prompts, as we'll soon see. And yeah, basically, once you train the T0 model on various tasks, you're gonna evaluate it on a held out set of tasks, like natural language inference. Okay, so let's go further here. Let me show you something. So to make this a bit more clear, because this prompting part is arguably the most important novelty, let's call it that way, in this paper. So here is a task of paraphrasing. We can see again, how is air traffic control? That's question one. We have question two, and we have a label. And here the label in the original data set is like numeric one. So we have 0, and 0 corresponds to, I think, like not duplicates or whatnot, or whatever. And in any case, here is one particular prompt that people contributed. So you can see here, question one, question two, that's the template, and then pick one. These questions are duplicates or not duplicates, and then you have choices, labels, so that's gonna map 0 to not duplicates or duplicates. So basically you can see that this thing here is a template, exact template for the actual instantiation we saw up there. So that's this thing here. So we have question, pick one, blah, blah, blah. So that's one particular template. But other than that, as I already mentioned, we have other types of prompts, like I received the questions, question one and question two, are they duplicates? And again, so you can see that semantics hasn't changed here, but it's syntax-wise, it's completely different, and that makes it tougher for the model to learn to solve that task. Similarly, for every other like task, you can see here the summary, different prompts. Let me show you in even more detail how these guys made this like happen. They basically created this let's call it template language, which helps automate the mapping from the original dataset examples to the input-output pair of examples using the natural language prompting. So here we can see the example of how this template language works. So we have a variable text, and it's going to be eventually replaced by some concrete like text. So we have here Mark told Pete many lies about himself, which Pete, etc. So that's one example, but you can imagine any other example in the dataset is going to pass through this scheme, and out comes the actual input. So here we'll have this replaced, and then in the previous sentence does the pronoun, and then they have span to text dot lower, which is a Python syntax, and we have span to text is he. So they ask, does the pronoun he refer to span one text? That's going to be Mark. So does it refer to Mark? Yes or no? Second example is here. We have text, and then here by he they mean Mark. Yes or no? So that's a second example, and then you can have a bunch of these. So text, in other words, blah, 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 true or false. So basically all of these templates are going to map the input examples into desired output format, and that's how they created these novel prompted datasets. Let's call them that way. Anyways, let me go back to the paper and let me show you a couple more things. So I mentioned tasks, and it's a heuristic. They mentioned... the authors are well aware that this is not ideal because sometimes you can learn certain skills here, and then even though you're testing the model on a held out dataset, you already learned the skill somewhere here. So it's hard to decouple skills, and they opted to do it this way of separating it by tasks. So we have like closed book Q&A, sentiment, classification, summarization, etc., etc. And every single task has multiple data sets. You can see here, even like we have 5 data sets in total for the summarization task. And then they have 4 like held out tasks, as well as this big bench like set of data sets. And they mentioned here that noting the grouping by task is an imperfect heuristic. We err on the side of organizing our task taxonomy based on the task format as opposed to required skill, largely based on conventions in the literature. So as you can see, this is pretty much still an open problem. How do you separate nicely the skills and the data sets from the held out ones so that you can evaluate the model in a fair fashion? And since they are comparing T0 with GPT-3, they say that additionally we do not train our main model on any data sets that GPT-3 used for evaluation, so that our main results will be a fair zero-shot comparison. We verify that data for those tasks is not leaked through the pre-training corpus. And I mean, this is a very tough problem. Even if I recall correctly, the original GPT-3 paper actually had problems with leaking, and subsequently they've done a post hoc analysis and determined that the fact that the data leaked did not cause the GPT-3 model to be much better on those tasks. But yeah, still, like once you're dealing with such a huge internet scale types of data sets, like the ones used for GPT-3 or T0 or T5 model upon which T0 is based on, you have these problems of like leaking, and as I said, you cannot decouple whether you learned a certain skill on the training data set and then try and evaluate the model on a totally different separate set of skills. So that's still an open problem in the whole NLP field. Anyways, I thought that was worth mentioning, so let me continue here. Okay, we saw this one, and I mentioned that T0 is based on T5. And actually, so the fact is, so the thing is, T5 was originally trained on this masked language modeling objective, and because they say here that it's quite different from the conditional text generation format used in our prompted datasets. So because of that, they actually took the T5 model that came from Google, and they additionally trained it as on a language modeling task, and they refer to that model as the T5 plus LM, and that's going to be used as a baseline throughout this paper in what is called T0. Okay, so let's see how the T0 is finally trained. They mentioned here at a high level, we assemble our multitask training mixture simply by combining all of the examples from all training datasets and shuffling the result. This is equivalent to sampling from each dataset in proportion to the number of examples in the dataset. So yeah, basically you take all of those question answering, summarization tasks, you take their examples, you map them using that template language, and then you just kind of shuffle all of those examples and train this model by just batching those. There are certain details here probably worth mentioning. So some datasets are like even 2 orders of magnitudes bigger than other ones. So if you just if you were to just sample using this naive scheme, the model would be overwhelmed by a couple of those super huge datasets, and so they have certain way to threshold the amount of examples coming from those bigger datasets in a nutshell. Okay, so let's see the results finally. We can see a comparison here between GPT family of models. So we have GPT-3 models here with different sizes. We have 6.7 billion, 13 billion, and 175. So that's the actual GPT-3 model, the biggest one. This is the T5 plus LM baseline, and this is T0 model. And we can see that most of the time on all of these tasks, the T0 is way better compared to GPT-3, so even the biggest one. Except on this dataset and except on HelloSwag dataset, which are amazing results considering that GPT-3 is way bigger compared to T0, like it's an order of magnitude bigger than T0. They argumented that on this task they perform worse because GPT-3 used certain specific techniques that were like developed for that specific task. And as for this one, I haven't seen any argument for why there is this huge gap in performance. I guess that's an interesting open question for further research. Okay, so they mentioned that note that Brown et al., so the GPT-3 paper authors, reports performance on a single prompt, whereas we report the median and interquartile range of performance across all prompts. So they basically say that the GPT-3 paper, they cherry-picked the best prompt and reported those results. And we can see that on the chart here, we have error bars for T0 and T5 plus LM baseline, but we don't have any error bars here. So this is the best case scenario, pretty much. The best prompt was cherry-picked for this GPT-3 model. So that's something worth keeping in mind. Whereas here, the model was evaluated on multiple prompts, and all of the results are plotted here, like using these error bars. Okay, let's continue. We have other results on this big benchmark, and again the trend is very similar. Only on this strategy QA is the T0 worse compared to these baselines, whereas the baselines now are not GPT-3. So keep that in mind. They are just some models that people from Google created those baselines for this big benchmark. Okay, so what's interesting here for me is the non-monotonic nature of these models. So quick mention here, we have T0, we know what it is. We have T0 plus and we have T0 plus plus. So T0 plus is just trained on additional data compared to T0, and T0 plus plus on even more data. So let me just briefly go and show you what exactly that is. So T0 plus is the same model but trained on a mixture that adds GPT-3's evaluation datasets. For T0++, we add GPT-3's and superglue datasets. Okay, so that's the difference. We have more data for these models. So what's interesting going back here is that this non-monotonic behavior. So on most tasks, we have that basically adding more data is a good thing. But then we have certain tasks like this logical deduction where we have the inverse here happening. So the model with the least data performs the best, and then as we are adding data, we have worse and worse performance. And I guess investigating what happened here, whether we had some overfitting or whatnot, would be worth a try, I guess. Okay, finally, let's see certain ablations they've done. The first one is training with various amounts of prompts per dataset, if that makes sense. So they take the T0 model, and they basically P equals 0 means there's 0 prompts. That means they're basically using T5 plus LM baseline. P equals 1 means for every data set they use a single prompt that was randomly chosen from the set of prompts, and P equals all is basically all of the prompts for each data set, which is on average I think around 8.1 or something. And we can see the results here on various different tasks. And we have this candlestick diagram. And you can see that the mean usually increases as we are adding. So the blue one is the p equals 0, the red one is the p equals 1, and the green one is the p equals all case. So we can see that the median is constantly improving pretty much. So the thing that worries me here is that the spread is way bigger when we set p equals to 1, but as we progress p to be equal to all, we basically have like smaller spread and we have like higher median. So that's cool. So now question I have here is whether this is a like consequence of actually adding the prompts, or is it just the fact that we have much more computation that went into training this p equals all model compared to these two models? So it'd be nice to overlay a comparison here of models that were trained with less prompts but had more compute time compared to these models here, if that makes sense. Okay, so they did, aside from this, another like ablation, and here they hold the number of prompts constant, so they use all prompts, but they vary. So they vary the number of data sets that were used to train the T0 model. So those were the T0, T0 plus, and T0 plus plus models. So what is interesting here is that it's not quite a clear cut which model is better here, because first of all, it seems like that T0 plus is overall worse compared to T0. Like it has bigger spread, and it most of the times even the median is lower compared to the T0 baseline. So I mean, yeah. And then we have a trend where once we add this super glue data set, we have a bump in performance here. But again, the spread is usually bigger, way bigger compared to T0. Here as well, compare this to this and compare this to this. This is definitely worth further investigation. I mean, it is obviously not, so this model here on this particular NLE task is definitely not robust. That means depending on how you pick your prompt, you're gonna have a huge like difference in your performance, and that's a bad thing. That means this model is not robust when we increase the amount of data. That will be like fun conclusion I have here. Okay, let me wrap up this paper mentioning this part here. So note that one of our templates is identical to Brown et al. Again, GPT-3 paper authors reported prompt. This prompt scores 58.8 accuracy on the API-based series, which is lower than the reported accuracy of 63.5 from the paper itself. So we can see a huge gap in performance between what the paper like reported and between what the actual API is offering. So that's a point of concern for me there. And they mentioned here that all other 9 prompts, however, yield roughly random guessing performance with median accuracy roughly equal to 50% and interquartile range 1.28. These results suggest that T0 is more robust to prompt formulation than GPT-3. So yeah, I think this is a nice supporting evidence that training the models like this will make the models more robust. So this offloads some of the work from those prompt programmer people. Maybe not so far in the future, prompt programming will cease to exist, and that's so sad. Anyways, I'm gonna wrap it up with mentioning this. We release all models trained in this paper in addition to the collection of prompts we created and our prompt annotation tool. So huge kudos to the authors for doing this. This whole BigScience workshop sounds very exciting. They have a supercomputer on disposal. They are doing very nice, interesting experiments, and they are open sourcing all of that along the way. So again, do check it out. And okay, guys, that's it for this video. If you found it useful, consider sharing it out with your friends, as well as subscribing to this YouTube channel. And finally, do join the Discord community. We have an ever-increasing number of smart people there, so definitely worth checking out. Until next time, bye-bye.